Okay. Ceri, please, the floor is yours.
Thanks, Roman. So I thought I would give you a whistle-stop tour of our field site. So it's taken some time to get here. We've been interrupted by various issues, which I will talk a little bit about, including the pandemic, which I won't mention because we're all sick of hearing about that. But I just thought it would be good to share some practical experiences of the adventure of going from a paper-based idea to something real in the field, because there's so much learning when you go between theory and actually trying it out for real. So the GeoEnergy Testbed is a research facility initiated by the British Geological Survey and the University of Nottingham, which comprises an instrumented borehole array. So it's a £6 million investment in a sustainable energy future, including money through the Energy Research Accelerator. So that is my compulsory funding slide. So on to the interesting bit. So it's a unique geoscience facility. We have boreholes drilled, which are essentially water wells. So this site, unlike actual storage sites, it's actually designed to study migration and leakage. So if we release a bit of the CO2 to the atmosphere, it's actually working. So unlike most sites, we actually want to see some CO2, because otherwise the guys with the soil gas and all the groundwater sensors are going to be very disappointed because they'll have nothing to look at. So the idea was we would provide a national facility to catalyse collaboration. So we're very keen to invite other researchers to come and work with us. We wanted to improve understanding of impacts and processes in the shallow subsurface. So we felt that there was a lot of work in the reservoir. We felt there was a lot of work at the surface. And we thought it would be good to study that bit in between. So what would the warning signs be if leakage occurred? So we're hoping that this won't happen at the big sites, but what are the things that we should look for? What's the smallest amount of CO2 we can detect? These are the kind of questions that we want to answer. We also want to enable development and testing of new monitoring technologies. So we've got some of the silixa fibre. We haven't got the helically wound, but we've got the constellation fibre. And we've got various other new sensors. We've got sensors from the University of Rome. We've got some commercial sensors. We've got some BGS toys in the ground, including electrical resistivity tomography. So we've got an awful lot to play with, and we have the soil gas station from BGR as well. So we've got sort of some good CO2 GeoNet collaboration going at the site. So we're hoping that this will allow us to ground truth our simulations and our models. So what does it look like really? Well, it kind of looks like a field. So as part of the planning permission, the idea was that we would put all of the wells underground, so that all of the wellheads are in chambers. So when you go to the field, you basically see there's a tank with some CO2, a pipe, a few bits going into the ground, and then just a field. And that was kind of how it was supposed to look, but it also means that if you invite people to come and look, you kind of go, ta-da, and they're kind of, where is it? But we've commissioned it with a monitoring array. We've got basically a little kite-shaped array around 2 injector wells. So our intention is to inject into the deeper sandstone at around 200 meters. And that should allow us to study migration in the subsurface, because we've basically thrown all of the sensors we could think of at this. And then we have shallow injection at a depth of around 10 meters, and that's where it's supposed to leak. So the idea is that the CO2 will come up around that shallow injection well, and should be really interesting to see what happens and what we can actually see at the surface and what we can detect. So as I said, we kind of threw everything at it. We've got acoustic sensors, electrical resistivity tomography, pressure sensors, microseismic array, groundwater, seismic reflection, baseline, core testing, soil gas concentration and flux, and microbiology. And you can see a couple of my colleagues in the field here. So we've got soil gas. As you can see, we've got the flux chamber. And these guys are sampling. We're trying to get a baseline of noble gases. So our intention is to put noble gas in with the CO2 to act as a tracer. So we need to know what's the background level of noble gas in the natural environment. And you can see from the core there that some of it's kind of interesting. That's the core near the very top. So that's around the injection depth. So basically it's a broken up mess. It's going to be very much based on secondary permeability, and I'm really excited to see where the CO2 ends up. I've got my own theory, but we'll see what actually happens. So, as I said, we've got food-grade CO2. We've got around 20 tonnes on site. Our plan is to inject around 8 tonnes at around 200 metres depth over a period of 4 to 5 days. And we also plan to inject around 5 tonnes for shallow injection over around sort of 10 to 12 days. So not at the same time. I'm kind of hoping that we can do the deep injection, see what happens in the shallow aquifer, and then do the shallow injection. But it kind of depends on which funding we get first, which is just kind of a hint to what the rest of my talk is going to be about, which is how kind of it's not the science that holds you up or sometimes steers you. Sometimes it's the other aspects that tell you what you're going to do next. So, as I said, I thought I would share a few experiences. So, I mean, firstly, we wanted to make sure that we built something people wanted to come and play. So we wanted to make sure that the researchers wanted to use the site. We thought about who would use it, what collaborations we had, how do we fund actually doing the injection, because unfortunately, having bits of kit in the field that slowly rust away is kind of expensive. You have to keep replacing bits. You'll get the odd incident like we had. So the CO2 sat on site in this big tank. You get a really warm summer, and the CO2 kind of slowly boils, basically. So you find that you have to let a little bit of CO2 out. But the tank, of course, is designed for safety. So if the pressure in the tank gets too high, it vents, which is quite dramatic. If you stood next to it, it's quite loud. It's kind of the volume of a vacuum cleaner, basically, and it can make you jump a bit if you weren't expecting it. And one of the times it did that, the valves just stuck open. So, you know, as I said, these little things come and get you. So that surprised us. That meant the valves had to be replaced. But it's all part of the learning curve. And I'm very happy to say that the University of Nottingham is the engineering side, so the tank is more their responsibility, and we're responsible for the rocks, which, since we haven't done any CO2 injection yet, are just kind of sitting there quietly at the moment. So I would say a word of warning for people who are developing pilot sites is to think very carefully about who's going to own and operate the site, how we achieve a societal license to operate, and what regulations are going to be triggered. And from the UK perspective, the regulations kind of change over time. As we learn more and more about CO2, the regulations are changing. So when we built this site, we needed planning permission to have all the stuff at the surface, and we needed a license from the Environment Agency to inject CO2. And then I came along after they'd got the license, and I said, you know what would be really good is if we added a tracer, so we can tell that that's our CO2. So that means we have to go back to the Environment Agency and try to get the license again. So it's kind of good to make sure there's good communication and a clear view up front about who's going to own it, who's going to operate it, exactly what you're going to put in the ground. The other big warning I will give you is think about where the CO2 is coming from. So you may not be siting it where the rocks are the best. You might be siting it where you can get the CO2 and where you can practically get it to site. Now, for us, it's not such a big issue because it's quite small. You can get a tanker to the site. But if you're doing something on a big scale, the idea of where you're going to get your CO2 from becomes really, really important. And particularly if you're doing a research project, the price of CO2 is quite variable. So I don't know if you remember a couple of years ago, we had a CO2 shortage, which was rather ironic when it's all shooting off into the atmosphere. But we actually had a CO2 shortage, and I was really glad that we weren't trying to inject, because we wouldn't have been able to get any more, or we wouldn't have been able to afford it. So obviously, when there's a CO2 shortage, food gets priority over research. So there's kind of all kinds of practicalities that you have to think about. And in terms of getting CO2, if you want to inject larger quantities than we are here, you kind of need to think about the contract, when it's going to be available. We saw, for example, with Aquistore, they get a smaller amount of CO2 because they're a research project. They get given the CO2 for free, whereas the paying customer kind of gets priority. So if you're planning a research project, you really need to think about when you're going to get the CO2, how it's going to come to you, and how you make sure you get that CO2 when you need it. As we all know, to get people into the field takes a lot of organisation. It takes lots of time, you have to make sure you give people plenty of warning. And you need to think about the lifetime of the facility. As I said, when it's in the field, it's open to the elements. Bits kind of need replacing on a regular basis. And then, of course, there's questions on construction and commissioning, site operation, closure, and can we attract contractors to deliver the infrastructure? And what can you actually install in the wells? What's your appetite for risk? So as scientists, we want to do the craziest things possible, and sometimes, as we heard yesterday, where they're trying to cause some minor earthquakes, well, below earthquakes, but they're trying to cause some minor induced seismicity. And that's kind of exciting, but you have to ask, what's your risk appetite? What are they actually going to let you put in the wells and they'll be happy with? So just to point out, the GTB is on a dairy farm, and we know that CO2 has a bit of a history with dairy farms. So the other thing to think about is keeping the site active, what research and other funds are available, capturing data in real time, and then how you release that data. So we talked yesterday about transparency and being open and honest, but that means that when the data says something you're not expecting, you kind of have to have the trust of the public where you're going, I'm not quite sure what it says, but it's fine. So, you have to kind of think about how you're going to communicate and what you're going to do when the data says something you're not expecting, and being ready to react quite quickly. So perhaps real-time data might not necessarily work, but perhaps giving yourself a week of grace time so you've got a chance to kind of interpret, understand the results before it goes out. So these are a few practical lessons that I've learned. So I will say, allow for extra space at your site. So I was kind of, I was like, okay, we've got to get all the stuff in the wells. I was really worried about how big do these wells need to be so we can get all of these sensors on the outside. And that's what I was really worried about. And what I didn't realize was that when you've got all the sensors in the wells, then you need the monitoring boxes on the surface. So we basically have a shipping container full of boxes of monitoring stuff, batteries, and don't forget to air condition it. I will say that to you now, because otherwise you will really wish that you had. So you'll see that giant cabinet here. So I was kind of like, oh, you're going to have like a little box at the top right? No, they've got a huge, great big cabinet, batteries, wires everywhere. So it's kind of important to allow that extra space. As field workers, I will also say how fantastic it is to have a little monitoring hut with a kettle, a fridge, and some civilized toilets nearby. It's very practical, but I tell you this, if you want researchers to come, having something a bit civilized is very worthwhile. And you'll also see that in the middle, I've got my colleagues doing their sampling for noble gases, and just having that extra kind of enclosed space in the field that people can stand in when it's chucking it down with rain, which it does a lot in the UK, is very worthwhile. And I also have one of the, on the bottom right, you'll see this is the microseismic box. So what they also didn't tell me was, as well as needing a box in the monitoring hut, they need a box right next to the well. Now, if I'd known this, we could have kind of planned around it, but it's one of those things you kind of learn as you're doing. I will say budget for add-ons and maintenance. There'll be things that people didn't even tell you needed. So you kind of go to the researchers, what do you need, what do you want? They'll tell you, and then they'll come back and go, and one of these, 3 of those, and 10 of those. And before you know where you are, that's kind of spent a lot more budget. So, as I mentioned before, the monitoring wells are all below the ground surface. Now, the kind of fun thing about that is that we discovered the water tables at a depth of about 1 meter. So you can imagine that the wellhead chambers normally have a bit of standing water at the bottom, and sometimes there's more than a little. So this is our high-tech solution. So these are tables which hold the monitoring boxes in the wellheads out of the water. Not much budget, but kind of important. We also found that manhole covers turned out to be kind of heavy. So we had to buy this is a fantastic manhole cover lifter. So you can kind of like lever the manhole cover off and move it out of the way without hurting your back. Fantastic. We have a shed for the tracer pumps. So I want to add some noble gases as tracers. And I have to say, sort of to all the men in the room, look, a shed. I'm not being sexist here, but whenever I tell people, men, there's a shed at the site, they suddenly, their eyes light up. and on the right-hand side, these are pressurized sample containers, something I didn't even realize that we needed. It makes sense, though. So you're kind of collecting pressurized samples out of the wells, and then you've got to get them back to the lab. Now, I was thinking we'd have the fancy tool where the containers are like in the tool and you take them off and you carry them away, but that's not what happened. So we suddenly had to spend a good few £1,000s on getting some pressurized sample containers so that we can get the pressurized samples from the field to the lab. As again, budget for add-ons and maintenance. Expect the unexpected. So I say this to all field workers, you know this already. So we've got a few examples here. So this is a very, very exciting magnetic tool. It has a giant magnet in it. So one thing I learned was if you've got ERT sensors, then you need to unplug those before you do this. So I had to call the guys kind of on the weekend, and I was like, I'm really sorry to bother you, but are the ERT sensors going to mind this NMR tool going into well? And they're like, just unplug them, it'll be fine. We tried sensing with gases. So this is the helicite called Gloria. So the idea was that we would kind of gently float this across the site, see if we could detect a test leakage we did at the surface. It turned out to be incredibly windy. So this is the high-tech solution from the soil gas team. You'll see that my colleague is carrying the sensor on his head across the site. So we have two heights. We have head height and trolley height. I will say that this is a photograph. So the week before, the weather was fantastic. Then the microseismic guys came to install the sensors downhole. I will also mention this was the third time. So that was something else unexpected. It turned out that the downhole conditions were so harsh that they kept damaging. So the microseismic sensors, it's on this big tube that goes down the hole, and it has little legs that stick out so that it stays in the right place in the borehole, gets good contact. And those little legs have a little kind of gasket to make sure that it's sealed. It turned out that the sort of sand particles in the water were basically eroding that to the point where it broke. So we had to try 3 times to install this. Because every time something would go wrong with the legs, and then they would have to pull it out of the hole. And you can imagine these legs sort of scraping up the inside of the hole as they had to pull it back out, fix it, and then try it again. So it took 3 times to try and install the microseismic gear. And then it snowed on us. So I'll just say that. Expect the unexpected weather. You will see here as well a bit of flooding. So there have been times when I've taken the top off the manhole cover to do some work in there, and the water's right up to the top. So at that point, you've got to get the pump. So just kind of having a bit of extra money for these budgets and spares and being ready for the unexpected is advisable. I will also warn you that small tasks can be the most challenging and cause you the longest delays. So actually trying to find, you'll see on the left, the guys are digging a hole. So this was to put the cables in. That was actually really hard to find a contractor because it's a small project. They want the multi-million-pound, let's build a power station projects. They don't want to come into a muddy field and dig you some trenches. And also, just for the fun of it here as well, they managed to bury one of the wellheads. So I'm kind of toddling around the field with the GPS going, I'm sure there was another one around here somewhere. And it turned out that when they were putting the soil back, they just kind of leveled it out a bit and just kind of buried one of the wells. Super. But I will also tell you a very, very tragic story here. So I thought, I'll try and guess where the well is. So I put a stick in the ground where I thought the wellhead was. I was only off by 2 feet. So that's how much time I have spent in this field. Also, in the middle is my colleague Humphrey. So that's the monitoring hut there. We didn't allow enough space to get the cables through the side of the monitoring hut. It turned out that the cables are a lot bigger than we expected. So trying to get the cables through the side of the monitoring hut turned out to be challenging. And because the hut belongs to Nottingham, we asked them, so will your guys do it? No, maybe. So we waited a while, and then we had to get our guys to do it. Then we had to get permission to make a hole in the side. And that held us up for months and months of waiting and trying and going backwards and forwards. So that tiny task of making a hole in the side of a shipping container held up the whole project by about 3 months. So those little tasks are the things that are going to upset you. And on the right, you will see one of my colleagues being very cold in the field. So when you put the well in, as Michael mentioned, sometimes you have a temporary casing to kind of hold the soil back. When you take that out, because you've got sensors up the side of the tubing inside that, sometimes you end up cutting those. And then some poor person has to sit in the field, in the cold, with a soldering iron, putting those tiny, tiny wires back together. So it's yeah, that things can keep you busy. But after all of those stories, I will say we are still smiling and we're still optimistic. So don't give up and keep smiling. And this is the only way in which to deflate the supporting ring for the helicite. It is the official way is to just lie down on it. But at that stage, you're also kind of tired. So thank you for your time.